So what is principle of least action? It states a particle moving under the influence of a force, any force like a gravitational force, it will take a path in such a manner that the time averaged kinetic energy of the particle minus the time averaged potential energy of the particle is a minimum. We call the sum of this difference in time averaged kinetic energy to potential energy as action. That is, S is, you can see S is equal to integral T0 to T kinetic energy minus potential energy. That is actually called action. So a particle moving under the influence of a force will take a path in which action is a minimum. So here you can see that a particle moving from point A to B, there are two paths shown. So it will select only the path in which the time average difference of kinetic energy to potential energy is a minimum. That is, action is a minimum. So S is T0 to T kinetic energy minus potential energy, and that path will be minimum, and the sum we call it as the action. So same thing is explained in another way as S is integral T1 to T2 L dt. What is L? L is the Lagrangian, and Lagrangian we already know that it is T minus V, that is kinetic energy minus potential energy. So the kinetic energy minus potential time average difference of kinetic energy to potential energy, which is called action, that should be a minimum. That is called the what is called Hamilton's principle. Okay, so the statement, we can state it like this: for a holonomic conservative system of all possible paths along which a dynamical system may move from one point to another within the given interval of time, the actual path followed is that which the action is stationary or extremum. That is, at this extremum means the variation will be zero. That is why delta integral t1 to t2 L dt is equal to 0. This is the mathematical statement of the principle of least action. Delta integral t1 to t2 L dt equal to 0. What is this delta? Delta refers to variation at the same instant of time. So here we have to explain the two types of variation. One is called this delta variation and another one is called D variation. What is delta variation? You can see here the two types of variation. One is called delta variation and another is called D variation. You know, in case of delta variation, it is a type of variation that occur at the same time instant. See, there are two possible paths shown by an object from A to B, that is executed by two paths, but at the same time that objects can be at two different paths. So then the variation between these two is called the delta Q. But at the same time, devariation means the variation that occur at two different times, like time t1 and t2. So the variation in the value of the coordinate at two different times is called devariation dq. The variation in the coordinate at the same time when the object is following two different paths is known as delta variation. That is here. Okay. So according to the Lagrange Hamilton's principle of least action, the delta variation of the sum of difference in kinetic and potential energies is zero, or the path followed by the particle is that at which the variation or the change in the time averaged kinetic energy to potential energy is a minimum. So delta of integral t1 to t2 kinetic energy minus potential energy, delta of integral t1 to t2 kinetic energy average minus potential energy average is a 0, or dt is equal to 0. This is the Hamilton's principle of least action. And we can derive the Lagrange's equation from Hamilton's principle of least action. Let us see how we can derive the Lagrange equation from Hamilton's principle of least action. Okay, so now we are going to derive Lagrange's equation from Hamilton's principle. So for that, let us consider the Hamilton's principle. What Hamilton's principle states is that the action should be a minimum. What is that? A particle moving from one point to another takes the path in which the action, that is delta S, is the action. What is that? The time average difference of kinetic energy minus potential energy. That should be a minimum. So that means delta S should be 0. Now we know that Lagrange is a function of coordinate qj and velocity qj dot. So we can write delta integral t1 to t2 L qj dot dt. We can write this as variations, that is delta of LQJ can be written as dou L by dou Q delta Q plus dou L by dou QJ dot delta QJ dot. Once again, Lagrangian is a function of QJ and QJ dot. So we can write this as in terms of variations, that is dou L by dou QJ delta QJ plus dou L by dou QJ dot delta QJ dot times dt equal to 0. Now integrating the second part of this equation. Second part means dou L by dou Qj dot delta Qj dot. So we are going to integrate this part. So integral T1 to T2 dou L by dou Qj dot delta Qj dot is equal to. We can integrate this by using the expression dou L by, that means first function times integral of a second minus integral of differential of first function times integral of the second function. Okay, so using that we'll get dou L by dou Qj dot integral of this delta Qj dot is delta Qj from T1 to T2 limit minus integral of differential of first function d by dt of dou L by dou Qj dot into integral of second, that is integral of delta Qj dot is delta Qj. Okay, but we know that delta Qj at final time is equal to delta Qj at initial time. That's equal to 0. That means we represented delta variation like this. Okay. What is delta variation? Variation at a particular time. This is delta. So here this is T1 and this is T2. You can see that at T1 the delta Q variation is 0. At T2 also the delta Q variation is 0. So at the starting point and final point there is no delta variation. Delta variation refers to the variation at the same time as shown here. There is no variation at the starting point and initial point. So that is why delta Qj is 0 at T1 and T2. So the first term moves to 0. Then what is remaining is only the second term. So integral T1 to T2, integral T1 to T2 dou L by dou Q dot, dou Qj dot delta Qj dt can be written as negative T1 integral T1 to T2 d by dt of dou L by dou Qj dot delta Qj dt. So using this we can write the expressions, say the expression A, integral T1 to T2 dou L by dou Qj minus, the second time is replaced by the plus d dou L by dou Qj dot delta Qj dot is replaced by d by dt of dou L by dou Qj. So here we are replacing this d by dt of dou L by dou Qj dot delta Qj dot dt is equal to 0. Now we know that delta Qj not equal to 0, dt not equal to 0. So what is remaining is the integrand must be 0. That is the term inside bracket must be 0. The other two terms outside are not 0. So the terms inside are 0. So what you can write is dou L by dou Qj minus d by dt of del by dou qj dot is equal to 0. Or you can write d by dt of del by dou qj dot minus del by dou qj is equal to 0. This is the Lagrange's equation. So hence we derived the Lagrange's equation from Hamilton's principle. Okay, students, thank you.